Hello and welcome to this demo of LoRaWAN FUOTA using AWS IoT Core for LoRaWAN. For this demo, we are using 3 STM32 Nucleo boards with SX1272 radio boards. The boards are already registered and connected on AWS IoT Core and running version 1.0.0 of the firmware. In this version, the LEDs on the boards toggles every 5 seconds. We are using a Tektelic gateway. In the LoRaWAN details, the connection status of the gateway is shown as connected, and it displays the time when it received the last uplink. In the device section, we can see the devices we have already connected. As mentioned before, we are using 3 Nucleo boards, named Device 1, Device 2, and Device 3. We can also see the last uplink received from each end device. Now we are going to create a multicast group for the 3 devices. Name the multicast group and click Next. Here, I am using the US 915 region. Select Class C for the multicast device class and choose Add Individual Devices. Copy the device ID of each device and add them one by one to the multicast group. After adding, click Create. After creating the multicast group, we can see the downlink message on port 200 for creating the multicast group. The multicast group is successfully created only after the multicast setup is ready on all 3 devices. Now I am creating the FUOTA tasks for the multicast group. Enter the name of the FUOTA task and select the RF region. Here, I am using the US 915 region. Click Next. Select the firmware file you are going to update and create the S3 bucket to store the firmware file. Since I have already created the S3 bucket, I will click Browse S3 and select the pre-created S3 bucket. In the Advanced Transmission Parameters, set the fragmentation size to 128 bytes based on my program, leave the fragment interval as 1, and set the redundancy % to 100. Click Next. Review the properties and configuration, and click Create. After creating the FUOTA tasks, add the multicast group that we created previously and click Create. Once the multicast group is added, schedule the FUOTA task by clicking Schedule Task. Select the date and time. I will set it to 30 minutes from the current time. Click Schedule. After creating the FUOTA task, check the Details section to see the status of the FUOTA task. It should show FUOTA session waiting, and you can see the FUOTA session start time based on the scheduled task. The downlink message on port 200 indicates that the FUOTA has been created successfully. In the multicast group, you can also see the FUOTA session start time and session timeout. In the MQTT test client, you can see the message received from the end device. At the FUOTA session start time, the end device stops sending uplinks to the network server, and the FUOTA session begins. The FUOTA session starts, and it begins receiving firmware fragments from the network server. The status of the task is now in FUOTA session. All the fragments are now received, and the device is rebooting. The board is now running with the new version 2.0.0, indicating that the firmware update was successful and the device has rejoined the network server. Now status of the FUOTA task is FUOTA done. The LED's blink time now changes to 1 second as per the new firmware version 2.0.0. With that, the firmware update over LoRaWAN using AWS IoT Core is completed. Thanks for watching.